Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Okay, so the first question is we should ask ourselves, what is Docker? And some of you are very comfortable with the Docker. So can we make this training as a discussion or interactive session so that way it will be good, sharing knowledge with each other. I can learn something from you, you can learn something from me, right? So what do you think? What is Docker?
It's a self-contained environment to run something.
Self-contained environment to run something. When I say that means to run
So
application.
many programs to run applications. Yeah.
Now, yeah, anyone else has any other definition?
Uh, Something like the Linux having the namespaces. Okay, this is an organization of namespaces in the Linux, so
Mhm.
that the each application, the Docker will each Docker container will get its own set of resources and
Mhm.
its own set of setups.
Yeah. So, yep, that's the organization of namespaces. That's something. I don't know, but there's some creepy noise coming, which is echoing our noise. Your voice, our voice is getting echoed. Is it for everyone or only for me?
It's for everybody. I think people who are not talking can please mute their mics.
Yeah. So it's this annoying sound actually. So it's very difficult to hear that. Okay. So yeah, one said organization of namespaces. That's the one thing. What else? Anyone else who would like to share the knowledge on this? No? Okay. So, yep, that's the right definition. There's no doubt about self-contained environment to run application. But also, someone has said organization of namespaces to power that stuff. So that is important. So that is something which is happening right now. Now, when I say here organization of NS, what is this? So I say Docker is a container management tool. Okay, Docker is a container management tool. There is a three word container management tool, or a platform also you can say, no problem, platform. Okay. Now, when I say platform, when I say tool or platform, what is the definition of tool? So if I read the books and see the definition of tool, then typically we've been using the tools from last 5,000 years, right? Different tools. So why we are always opting for the new tools? And the reason you know that, it save our time, correct? Save our time. That's important. Time is everything, right? Save our cost also. Save our cost and improve efficiencies. That is the three reasons typically you use a different tool, and that's the reason we are increasing. I mean, changing the tools every now and then, right? Every years with the tools get changed. Some of you might be frustrated, but because of this reason, we always looking for the saving our time, precious time, saving cost, and improving efficiencies. That's the definition of tool management. I think I don't have to define it because typical word we use every time. But for what management? Container management. So the question is in my mind here, what is container? Okay, what is container? What is container? So that is the question in my mind. Now this, I ask a question here, what is Docker? And someone says self-contained environment to run app. I would say this is a wrong definition. So why is that so? So because I ask Docker, not a container. You define a container. You said self-contained environment to run app. So what is this? So basically this should be part of what is container. Organization of namespace should be a part of container, not a Docker, because Docker is a tool. Docker is a platform which manages the container, and inside the container what we want to know that. Okay, this is the perfect definition, but for the question which is what is container. Now I don't know how many of you have understood this. We will deep dive into that and we'll get into that. But did you understand that what is Docker? It's a container management tool. Now what is container? I don't know. What is container in a way we should understand? I don't know, but we'll come to know in some time. But is that okay? What is Docker? Did you understand this?
Yep.
Yes.
Yeah.
Okay, guys.
Yeah.
Now I would request you to leave and forget about the containers and Docker. Forget about this. I'm not talking about Docker anymore. I'm not talking about the container anymore. I am talking about one very simple question, which is should be we all should be knowing, and that is how applications can run. Simple. I'll put it, reword these questions. What are the components needed to run any application? I'm not saying one application A, B, C. I'm saying any applications. Okay. What are the prerequisites? Again, I'm rewriting this question. What are the prerequisites for running any application or AKA software in simple word? This is my question. So I would like you to forget about this Docker because we don't need Docker anymore. We don't need containers anymore. If you answer these questions, everything will be clear in just a matter of 5 minutes. So do you know what are the things needed? What are the components needed to run any application? Do you know that? Let's say there's one application you want to run Apache. I'm just giving one example, okay? It can be any applications for the sake of it. So tell me, look in
You need
your
hardware,
Okay.
you need operating system.
Okay.
wonderful.
Hardware OS.
So you need a hardware. On top of that, you need operating
Operating
system.
system.
What else?
And
You
then
need
this it should
some.
work out.
You
What?
need some
All your dependencies, libraries.
Okay,
dependencies.
operating system, and then you need a JDK. Let's say this is a application which is a Java based. Let's say Java software. Okay, so you need a JDK, Java
GRE,
Development
yeah,
Kit,
not GRE, not JDK, GRE, right?
JRE.
For
JDK has an inbuilt JRE, so I've got to have it of it. Yeah. So JDK or JRE, right? So after that, you have a application which is a software Java X. Is that correct?
Yes.
Guys, we have to deep dive into the same model again one more time. When I say hardware, what exactly this is? So when I say hardware, typically we have
CPUs,
RAM,
compute.
RAM, memory,
CPU, and storage. Correct? No?
storage. Yeah.
So this CPU is important because RAM is a secondary processing unit, right? You know that we have studied this in the semester one also. So this is the important one, CPU, RAM, and hardware. So this is the hardware. But when I say operating system, guys, what is this? Operating system as well.
Kernel codes.
So we have kernel. Wonderful. Now, do you know what are there inside the kernel? Anyone?
It's in- a middleware to interact with the hardware.
Yeah. But I think someone
Files.
said. the next step here. When I ask what is Docker, someone said actually.
The namespaces.
Yes, absolutely. So this is a namespace. Here you have a C group. Here you have a compatibility. Now these keywords probably might be new for some of you, but it will not be new anymore because we will discuss now. What is this namespace? Understand that pictorially, if you create this diagram, probably it will be long. We'll remember this in long run. So guys, when I say running applications, so typically what have we have this is the one. It should go up, right? This WebEx stuff should go up, but it's not moving up. Now it's gonna. So this is the hardware, okay? And on top of that, you have a operating system. And when I say operating system, you have what? Kernel. Okay, so understand that. On the top of the kernel, this I'll leave it blank for time being. Okay, this I'll leave it blank. Now you create one user, let's say user one. You can create a more user also, guys. But you run applications with a certain specific user, don't you think so? Right? Have you
Yes,
run
yes.
have you run any application without a user? Any
No,
application?
no.
No.
So basically, we need a user space, user isolation. This is the one. It's a user. Rajesh, Apache, Tomcat, MySQL, this, that. We need user to run what? Applications. So here I am running Apache here. Let's say this is me. I logged into this machine. Let's say this is logged in by someone else. And he is also running applications. One machines, multiple people can log in. You know that in Linux. So here we are running applications. Now, so one thing we got to know to run applications, to run applications, we don't need a GDK, but we need an operating system. On top of operating system, we need a user space. Correct? Correct, right? Correct, right? In
Yeah.
after
Yeah.
operating system,
Yes.
one user space we needed, right?
Yes.
Yes.
The next question is, guys, this Apache you are running, okay, fine, no problem. Now, this Apache need to be accessible to the outside of the world. Yes, that's I'm saying. Let's say I'm running applications here. You should access, but how can you access? Because you don't have a physical access to the software. So what is required?
Network interface.
Networking. Yes, networking. So here one more thing which is required: network. Wonderful. So we need network, and you know why we need it. Guys, each application when you run, it get CPU allocation, RAM allocations, correct? Now, do you know how this CPU and RAM getting allocated to the to the system in the system?
It depends on the C group to which it belongs.
But let me show you. I think you will recollect this. See, guys, this is my Windows, nothing new, you know that here. And go to the detailed view because this is a simple view. I'll go in the detailed view. See, there's many software I'm running, and to be honest, I'm having so many software, and most of the 90% of the software, what exactly they are running in Windows, I don't know, to be honest. And I'm fed up with this. But anyways, they are getting the CPU allocated for each of these processors. You see here,
Yeah.
38, 40, and all. So how do they assign the CPU? Do you have any idea?
Scheduling.
Look at this. Something else is missing. How each CPU get allocated?
Process IDs.
Yes, CPU get allocated to process ID, guys. Now this question is how this process ID get created? That's a question, right? How a process ID get created? Anyone has idea? Anyone has idea?
Based upon the user.
Based upon the PID name.
Oh, wonderful. So basically, guys, forget about this rest of the things. You need a one process table. We call it PMAP, process map. Okay, you can study a little bit later. This is process map. Okay, PID table we call it. So basically, we need a PID table, and you know one thing. I'll tell you interesting thing. When you get a one PID, you always start with a zero and then one like this, and then 4 5 6 7 8. So it's like a map. Okay, if you want to see that, when you have one operating system you run, always start with a zero, right? Everything get appeared from zero. That's true. We've been reading this stuff. Everything has come from nothing actually, and that's a true statement. So everything come from the zero actually, and from the zero to one, 4, 5, 10, 20, all this thing map get created. These are the process ID I'm talking about. Okay. So this whole things, how did it come? Because of some namespaces, I'll talk about it later. But actually, if you want to run any application, look at this, there's so many application running. You want to see the chrome.exes, this is my browser, right? So I got to know, I learned that to run any application, these are the running application. Remember, these are, you know that these are running, you see here, running, only running application you can see here. So these are running applications. Totally. So these are the running app. I think there's some coming from background.
Sanjeeva, yeah,
Can you please
Yeah.
mute yourself? I'm so sorry, but some different noise. It's when it comes, it annoy because I'm using very powerful headphone, so it annoys my ear actually. So I'm so sorry for that. Okay, so yeah, so these are the application which you are running, and actually it's running with the PID. CPU get allocated to the process ID. So now the question is, in order to run applications, you need a one process map also. PMAP, right? PMAP, PMAP. Okay, so these are the things you needed. One more things we needed, and that is, guys, when you run applications, you run these applications. Let's talk about. Let me show you one applications. Okay, and here this applications files are stored where? You know where is this being stored? Where this is being stored?
App data.
No, no. All these files where is being stored?
Hard drive.
Some files. RAM. Next.
Oh no, RAM means storage, right?
Program files.
Windows
Yeah,
accessories, right? Partition.
program files, right?
Program files.
So here, application which I'm running here, and this is stored, right? Typically program files, but I have a habit of creating a tools also. So see here, Java is installed here. So this is the storage. Now, in order to run application, you need a storage. Without storage, you cannot do that, right? Storage, correct? Now, so you need a storage. So guys, these are the minimum things which you need it in order to get the application running. But where? In operating system. Operating system has what? Kernel. You only answered to me that I didn't know that. User space. So now we are needing this stuff, user space. That means simple way. The question was again same, how to run application. So in order to run application, we need one user, we need one PMAP, one you need a one network, you need a one storage. Okay. Now, by the way, do you know from where this is coming from? Do you know from where this is coming from? So, guys, this is coming from namespace. Now, what is a namespace? I will put the simple keyword. It's a library, guys. That's all. It's a C libraries. It's a library. It's a code. I think some of you are programmer also. And do you know the concept of object? Classes, sorry,
Yes.
classes.
Yeah.
So when you instantiate classes, what you get?
Object.
Object.
From one classes, how many objects you can get it?
N.
Correct.
Number of.
Yes. So guys, this is something similar. I'm not telling you exactly it's a class, but it's something similar actually. So here what is happening? This is concept, we'll call it namespace. In short, it's a library. If you initiate one time, you get one time. You get two times. If you initiate it two times, you get it two times. The properties will remain same. That's what it is. So now these are the namespaces. So we have a user namespaces. Yes. We have a PID namespaces. We have net namespaces. We have MNT namespaces for storage. So these are the namespaces, guys. These are the libraries. We call it namespace in the world of kernel. We call it namespaces. So now the question is, guys, in operating system, how many times you can create a user? You tell me, how many times you can create a user?
Unlimited.
One many users, but only
Yes.
one per user.
Yeah. So you can create multiple user, guys. That is allowed. Multiple user, unlimited user are allowed, right? Multiple unlimited user allowed. That is the one thing. But do you know how many, when you boot up one operating system, how many PID you get it? PID means process map. How many you get it?
The
I'll put it in a different way if you don't understand the PID. Let me tell you, if you're running two applications, A and B, will you get the same PID for this and this one ever?
No. No.
No.
no,
Then how many PID we have it?
2.
One. PID, see here, PID means process map. Everything starts from the zero and then from there it derives. So here you get one PID. One.
Just a question. Just a question. Each user will have a separate PID, or the overall system will have one PID.
You only see, in front of my screen, how many PID you have. Because
1.
see, one you have. So now let me tell you here, Rajesh is logged in. He can see this one.
Yeah.
Rakesh will log in. Will he see different thing? Will he see different thing? Tell me.
no,
No.
Same thing. So that means how many PID? Here, all user, understand that. Here, all user is accessing only one PID, one PID table. Now, guys, how many network get initialized in your computer? I'll put it in a simple way. Okay, I'll put it in simple way. Let's say you are running two applications. Two applications. Have you seen that port number same for the both applications in one machine?
Yeah.
Have you
Yes.
seen?
Yeah. It's
Port
possible.
number same. Are you sure?
No. No. No.
Actually, when you do search,
Port
two application will
port
have
number should be different, right, for every
Port
application.
number, but the one person will see the other person's port number.
Huh, that
yes.
seeing is okay, but I'm saying, let's say this application you are running on 80 port. Can I run the B application also on 80 port? Is that possible?
No.
No, it will clash.
It will not allow. The question is where the root reason for it. So guys, the root reason is when you initialize the operating system, you get a one network namespace. That's the reason the port cannot be duplicated because of this reason. See here. Now guys, mount. This is little bit tricky, but I will try to simplify this. Okay. Here, how many mounts you have seen in an operating system? Let me simplify this question. Mount when
Multiples.
when I say, have you seen the 2C drive in one operating system?
No.
2C drive. Have you seen that, let's say Linux? Have you seen the 2 OPT in one operating system?
No.
no,
So how many mounts you get?
One.
So see here. Now understand this way, guys. All this come from this one namespace of PID come from the PID namespace. This one namespace which comes from the network namespace. This one namespace of MNT come from the MNT namespace. So basically, but here you can have a one namespace which is a user namespace, but you are allowed to create as many users you wanted. So that means logically, if I see that if I create more PID, more net, more MNT, that's possible. That's possible. Don't you think so? It's all about initializing the namespace. Correct, right?
Yeah,
So,
initially,
one question here. So, when you say namespace lib, right? So, namespace lib, when you instantiate, we mentioned like user namespace unlimited PID one net one. So, for every namespace initialization, this will get initialized, or
For every
every namespace, as you mentioned, like
no,
if
no,
we
no.
consider.
I'll draw a picture. I'll
Okay.
complete the
Yeah.
picture. Probably you understand. See here.
Yeah.
This is operating system. Operating system has kernel, and kernel has namespace, C groups, capabilities. I'll talk about one by one, but understand that. So far, what we discussed about is you get whenever you boot the system, you get one network.
Yeah.
Okay, and shared by all the user. Understand that. That's a look at the image. Actually, that's the reason I'm drawing this picture. Shared by all users, same network.
Okay.
Okay, you create one pmap
Mm.
and one mount. So
Okay.
here you see here, this mount, this process map, this network is shared by all users. That
Yes.
means this user is having access to the shared network, shared mount, shared pmap. So this is what I was talking about. One,
Yeah.
one, one, but multiple user. One user,
Yes.
two user, two, three user, 100 user. Make sense?
Yes. Understood.
Yeah. So here, this is thing. Now the question is, can I create it? More namespaces? Answer is yes. Can I create a more PID, more net, more MNT? Answer is yes. But why we are not doing it? The reason is PC concept. What is a PC? Anyone?
Personal computer.
Yes.
program.
No, 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 no. First one is correct. Personal computing. Okay. So this is the personal computing. What is the reason for not duplicating namespaces multiple these namespaces multiple times? Personal computing. Now you must be wondering what is the what is this logic? So understand that when 50 years before, when operating system was designed, it was designed for the human use. Understand that evolution. It was designed for the personal computing as a personal computing devices till the internet comes. Okay, so it was so Microsoft designed the operating system, Unix guys designed the operating system, Linux also designed the operating system, Mac operating system, all this thing whatever you see in the world, they design the operating system so it should be used by as a personal computing. Means when I say personal computing, that means who will be using this compute device?
One person.
One person, human will do that. So now when I design a product for the human as a PC concept, then what you will do the multiple C drive, what you will do the multiple network, what you will do the multiple PID. Yes, maybe your family and friends might want to work. Someone has a more privilege, someone is having less privilege. So let me allow. Microsoft allowed you to create a multiple user. Linux allowed you to create a multiple user. So they allowed you to create because it was for the PC concept. But with the inception of internet, everything we are not running in the laptop, desktop, where we are running. All of our application is running somewhere else. Computing needs not in your laptop. Maybe you're a software engineer, so you may think, okay, I need that. But I'm talking about, let's say, my mother. Does not need any computing because her application is running in the cloud data center. So you look at this, what are the application you're using on day-to-day activities? WhatsApp, ICICI Bank, HDFC Bank, Make My Trip, what else? Instagram, LinkedIn, Facebook, Google Docs, 365, slides, this, that, whatever application, Gmail, video call, whatever the video call and the WebEx, everything is running not in your computer, it is running in data center. It is running in data center. So where the computing needs? There, not here. You need only to compute to run your browser. Only devices like Android, applications like Android app and all.
To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely.
So guys, then this was the reason they did not duplicate. Now the question was, how do we run app? So we got to know, in order to run any app, you need these namespaces, and these namespaces, and then you need CPU allocation from the host machine. So who will do that CPU allocations? C groups will do that CPU allocation. So this C groups will allocating a CPU to PID. Okay. So here you see here in this table, CPU getting allocated to the PID. Okay. How come? So who's doing it? C groups. It's there in the Windows also, it's in Linux also. Guys, some users, this user I'm talking about, some user is root user and some user is non-root user. Who decides? How come this guy get every access? This guy get no access? How come it's possible? Where it's been decided? Have you got the thinking? Have you thought
UID.
about? Have you thought about it? How that is possible? Some user you create, that guy has no access, limited access, but some guy has everything. So how that has been decided in operating system? Have you thought about it?
UIDs.
User namespace.
User namespace is isolated copy, but how it's empowered? Each user, because it's a user namespace, it's a user namespace, it's a user namespace. So how this guy is having more privileges to access more resources, but this guy cannot do that. So guys, answer is hidden in capabilities. So here all the access, root access, non-root access is been handled by capabilities. So whenever you say some user will act like a root, some user will not act a root, you modify the capabilities. So guys, where these namespaces, C groups and capabilities are? These are in kernel. Where is the kernel is in OS. So basically, in order to run applications, you got to know that, yes, in order to run applications, you need a hardware, you need operating system, you need these namespaces, you need a C groups, you need a capabilities, and on top of it, you need a JDK, and then top of it, you run Java. Make sense? Java. Did you understand that?
Yeah.
So guys,
Yes.
this was the answer for this question. Forget about the container, forget about the Docker. I don't need those topics right now. This is the. So is that clear for everyone? What are the components needed to run any application in operating system, whatever it is?
Yep.
Yes.
Now guys, one more thing I would like to tell you here, which is very important. What does that MNT means? So MNT basically we say mount, but you know one thing, I should tell you in a simple way what is a mount stand for. File system. Yes, I said systems. Don't think it's a one file system. Do you know the file system, right? What is a file system?
The format or schema in how the data is organized.
Yeah, data means files, directories, is like a file.
Anything.
Yeah. So guys, you know one thing, in operating system, when I look at it, you can see my desktop, my laptop itself, it has a certain file system where the real file source code is being stored, your data is being stored. So the one of the file system we call it a boot file system. Okay, all which boot file system. Can you see boot file system? No. What is this? It's a kernel. Have you seen the kernel files while running the operating system?
No.
No, you cannot say. It's
No.
get loaded in your memory, and that's how the application runs. Okay, this get loaded. So boot file system, you cannot see it. Kernel file system, and it's very important topic, guys. Understand that. If you have doubts, please clarify now itself, because when I say next time MNT, and this MNT I'll be using throughout the day and tomorrow also. I mean next class also. So here you have a boot file system, which is a kernel file system code, the one which all this code which I was talking about. Okay, now then we have a one more file system which is called it a root file system. Now root file system, you can see it. So you want to see that what is a root file system? So let me Google it rather than, probably you will get to know immediately. It will be in your memory. Guys, have you seen this kind of file system anywhere?
Yeah.
Yeah.
Then,
Can you see? Have you seen this one? Of course, you might have seen it, right? opt,
yeah.
root, sbin, temp, lib, media, this, that, and all. Have you seen this?
Yes.
Yes.
In Windows, have you seen the C drive, D drive? Let me show you. C drive, this is the C drive, and then program files, program data, Windows. So guys, these are the root file system. That means whenever you install any operating system, you get to see that. Yes, you can see that. This is called root file system. Basically, you interact with it. Okay, and then we have user file system. What is a user file system? User file system. Have you seen this? Let me show you my desktop. Look at my desktop. The file system which is dedicated to you. So my file system is starting from the CMD. If I go to user home, this is the file system which I will see it. Being Rajesh Kumar, this is my file system. Here you have everything. Now, do you think Rakesh can see it, this one? Can Rakesh, other user can see this one?
No.
No, this is my file system. It has a isolation. Yeah, root can see it, but not normal user can see it. So here you have a desktop. So guys, here we have user file system. And then you will also have one more file system, and that is called application file system. What is the application file system? You want me to show you? Look at this. All the tools I installed here under the tools. You want to know the JMeter app file system? These are the ones. Do you want to know that Git file system? These are the ones. Do you want to know Java file system? These are the ones. So yes, did you understand the application file system?
Yes.
So guys, when you basically start any operating system, you get this one, three file system. Okay, you get a three file system in operating system, and you bring your application and plus dependencies, whatever. Dependencies also is applications, understand? Make sense, guys?
Yes.
Yes.
Okay, so I think we got the answer for this. Now back to the questions, our major questions, main question, what is Docker? So guys, Docker, I said very clearly, is a container management tool. But the question is, what is container? That's the question. So now let's understand this. In order to understand the containers, we have to go into the history of the computing. So let's go 30 years from now, 15 years from now, and now. This is the timeline of computing evolution. So tell me, 30 years from now, how we were running the applications? In what way you were running applications?
On a single console. single destiny.
Okay, I'll answer this question. Maybe I'll confuse you. So don't you think we were running application in the physical server?
Yes.
So let me tell you, in a physical server, do you get operating system?
Yes.
Do you get a kernel?
Correct.
Do you get a namespace, C groups and capabilities?
Yes.
On top of that, install JDK and JavaX, which is application file system, and enjoy running application. That's what. So 30 years from now, in the past, you were running application in physical server. Okay, that was good. But guys, then suddenly the internet comes. So when internet comes, then you wanted to run application not in a physical server, but in a data center, not in your laptop. Let's say you must be using MS Office, Windows operating system, Tally, Photoshop. These are the desktop based solutions, right? Desktop based software. But when internet arrived in 1990s, okay, I think it's been 30 years, I guess, since internet. Yeah. So when internet arrived, then you wanted to run application in a data center, not in a physical server. Like many organization has pop up, like that some of the organization like a Hotmail. I think first email account which I created with the help of my senior is a Hotmail in my college time, right? Hotmail. I created an account. I think I used to get 5 MB space. So right now I'm using Gmail. Do you have any idea how much storage you have in the Gmail free of cost?
15 GB.
30
15
GB.
GB. Yeah, 15 GB we are getting free of cost. See the difference, guys. You only visualize this in your mind. It's all about the visualization. No one can help you to visualization. I started with the 5 MB and now you are getting 15 GB. Such a huge difference. Huge difference. And everything is free of cost. The question is, are you paying for Facebook? Are you paying for Google searches, which you cannot survive actually? Are you paying for Google Maps? Are you paying for LinkedIn for building your career? Are you paying for talking with your family like WhatsApp and this that? No, you are not paying. Think about those organizations those who are running applications. Your application, you have started taking those organization and those models for granted. But have you thought about it? How come this organization is surviving without any charges? Because the Gmail don't charge, Google searches don't charge, and Facebook don't charge. So you must be thinking, oh, they are running lots of ads and they're making lots of money. But do you know one thing? How much money they make? Let me tell you. The CPC rate, which I get it on my blogging website, is 1,000 per click. Per 1,000 CPC rate is 1,000 view per click. That means in a simple way, I'll tell you how many people will browse my website. 1,000 people. Out of which how many people will click on ad? 1 people. That means if he clicks on ad, that money will be divided into 2 parts. One is like a ads provider like a Google and me. Okay, now you see, think about it. Your prospective user is only one in an ads market, but you need to run application without even a single second of downtime for how many people? 1,000. This is how ads typically works. I mean, there are different model, of course, but I'm not getting into depth. But this is, I'm trying to help you to visualize this. Guys, you need to run application for 1,000 people, out of which only 1 people will do the click on ads. Then we'll get a money. Google will get a money and I will get a money. Website owner will get a money. Are you getting my points here? Hello? Am I got disconnected?
Yes, I mean, you get it.
So,
They are connected.
so the problem here is Problem for the organization is how come they can run so much of applications, not one or two. Now I'm talking about thousands of applications, but at a lesser cost. See here, same thing I said, right? Save our cost. So how come? So tell me, what has happened with the internet? Something has happened. Tell me. When we got the internet, where we started running our applications?
The physical infrastructure has gone down,
Yeah,
so
and then
shared
replaced by
infrastructure, a cloud, I mean, somewhere.
Data center clouds.
Data centers.
can I call it virtualization?
Correct.
Yeah.
So virtualization is the right word because you have a different kind of cloud again under the virtualization, like a public cloud, private cloud, hybrid cloud, this, that, and all stuff like that. So I'm not getting into that world, but you understand that virtualization very well because it's not something new, it's very old technologies, right? Okay. So now we got into the virtualization. So we need to visualize a little bit. See here. MS spent. See here. Earlier, this was the last model. We got one physical machines, okay, and then on top of that, this is the hardware layer. On top of that, this is operating system. Guys, when I say operating system, please remember all the time this one, okay. And then on top of that, user, and top of that, applications. Now, when I say user, that means they get all the three layers here initialized. Understand that? Okay, three layers which I have already explained it this way. Okay, so now this is how you used to run applications. So now let me tell you here, when you have peak hours, you need a 10 GB. Non-peak hours, you need a 2 GB. So when you have a such kind of requirement, 10 GB and versus 2 GB RAM, I'm just talking about the RAM. So which configuration of physical machines you will opt for it?
You have to use 10 GB.
Of course, very simple logic. Because you said, boss, this is a peak hours, 10 GB. I don't want to give the bad experience to the user during the peak hours. So let's go for the 10 GB. What's the problem? But if you look at this, there's one problem is there. If you look at the average utilization, 4 GB. That means this whole infrastructure is getting wasted. Let's say 6 GB or whatever it is, getting wasted is 2. Let's say you're running 100 machine, 100 physical machine. That means 60% of your cost or 70% of the cost you are incurring because of this model. So this is a drawback. So now the question is, what are waste here? So we got migrated into the virtualization concept. So now let me draw a virtualization now, parallel to the same image. So guys, here you have a large infrastructure, hardware, and top of that you have a kernel, operating system, and top of that you install one hypervisor. Hypervisor, can you name it, some of the hypervisor?
ESX server.
Yeah.
WebKVM.
Hyper-V.
No, VMware, that's a best one. Why we have to go very far? VMware is a hypervisor. VirtualBox is a hypervisor. KVM, Zen, many things are hypervisor. Okay, so
Okay.
yeah, so these are the hypervisor. Hypervisor will do one. Now what they are saying, hypervisor companies like a VMware, which is a leading hypervisor company, they say, boss, don't run application in physical box. Then we started asking VMware, okay, fine, I will not run in the physical box. Where should I run it? They said run in the VM. So then I'll ask, would you give me this one? Would you give me all this stuff? If I run in your VM virtual machines, would you give me capabilities, C groups, namespace, kernel, operating system? Would you give me, because my application needs this. Run it.
Yeah.
So then virtualization company said, VM said,
Okay.
hello, guys. Yeah. So then VMware said, yeah, I'll give it to you. So on hypervisor, which manage the VMs, one VM, two VMs. In the VM, what do you have, guys?
Operating system.
Operating system. And then how many user we create? Only one. Remember, only one. And then we run applications. Now, because of these applications has operating system, and operating system has all of which. So this guy is happy. This guy is also happy. But because of this, you could reduce the server cost. I'm talking the data center. Don't think about yourself at the high, the running application at the large scale. So you can save this cost from 80%, 60% of wastage to, let's say, wastage now only 15%. Only 15%. Okay. Okay. This is a reduce the. So now from last so many years, when you say, I want to run this application, and your colleague says, okay, what's the big deal? Run a virtual machines. Create a virtual machines. Right, guys?
Yeah.
But the
Yeah.
problem here is, guys, earlier we were happy with the 100 MB of Gmail. Remember Gmail when it got introduced, they were offering 100 MB. Now 15 GB. Unlimited Facebook, unlimited YouTube. You can upload hundreds of videos. Let me tell you, I have uploaded on YouTube more than 500 videos so far, and they charge me nothing actually. Remember 500 videos, if I give it to you to store it, you will start crying. Boss, I don't have a storage, right? You'll have to pay for it. So think about it. So many files you upload on Facebook, they never complain. So many videos you upload on the YouTube and different channels, they never complain. So many things you do, they never complain. In fact, WhatsApp nowadays we have so much of files which is stored in the cloud, they never complain. So virtualization is not working. Why? The reason is very simple, guys. Earlier, we were consuming the internet. We were using the internet for accessing some of the knowledge or something. But you know one thing? Right now, in the today's world, we are living on the internet. Trust me, you are living on the internet. Okay, knowingly and unknowingly. Let me tell you one of the incident which has happened in 2 3 days back. I was trying Vodafone SIM, okay, and I enabled the internet data card, okay, and the Vodafone SIM, the internet was not enabled. I mean, the data pack was not enabled, okay, and within a 5 minutes, I did not browse any website. Within a 5 minutes, just I enabled the data options for the Vodafone, and within a 5 minutes it's consumed 200 MB and it charged me around 80 rupees or 70 rupees or something because the data plan was not enabled. That means without me doing something, automatically the devices has used 200 MB. How come? So we are consuming now, we are using that, we are living on the internet. So when we are living on the internet, organizations has certain challenges. What challenges? Earlier we had hardly few crore people were using internet based applications. Now everyone is not using, they are living on it every day and night, connected with the devices, and always syncing, always logged in, session is always live. Earlier we were doing the login and log out. Nowadays we don't even do the login and log out. Okay, now the question is, how can we reduce the runtime application, running application in a data center further? That's a question. So do you have answer for it? Karthik, can you please mute yourself? Karthik, are you there? Yeah. So guys, the question is, how can you reduce the cost of the running application further? Now what should we do? So you tell me, what should be doing?
Remove the host operating system and use a single operating system.
Okay, good. Let me do that. So guys, as per the suggestion, I'm doing the same thing. What I will do, this is the hardware layer. And
Sorry, I meant a guest operating system.
so here, operating system. So you are saying remove this operating system, right?
Yes.
And this also, right?
Yes.
So if you remove this one and this one, then this also remove this heavyweight. It's consumed lots of CPU and lots of RAM, hypervisor.
Yeah.
So yes, wonderful thing. Okay, fine. This is operating system. Guys, if you remember, operating system give you only one network, only one mount, only one pit. I hope you remember, right?
Yeah.
Okay. Now I will create one user here, and this user is running Apache. What about other applications? I will create one more user
They have to share. There's no separate.
and one more Apache. I'll create one more user because here I wanted to run two user. No, let's make it three user here. Three user run Apache. Okay, you can use same user to run three Apache also, or three user to run Apache, three user to run three Apache. Hardly matters. But the question is, this Apache, guys, understand that problem. This Apache is using port number 80. Can I use this 80?
No.
Can I use here this 80? Of course no.
No.
Why? What is the reason? What is the reason?
It's
One
using
net.
the same namespace.
One name.
Already used. One in the space.
Guys, this Apache is writing a file in C Apache. Okay, this is the location. Now, if I write the same this Apache also in C Apache, don't you think the data integrity problem will happen?
Yes.
Yes.
So not recommended because we have to have a data safety also, right? No. Now, guys, this PID number is 50. Do you think the PID will get 50 here also?
No.
Definitely no.
No. The reason you know that by now. Why? Because one PID, one mount, one network. You got this right?
Yes.
So now the question is very simple, guys. It's not possible. So now I will load balance. Let's say I want to access from the outside. For you, I want to make this application available. And do you know the load balancer rule, everyone? Please tell me.
Yeah.
What is the load balancer rule?
So I mean, modulo number of application by modulo.
No, rule of the load balancer. Different IP address and
I mean, it depends. I mean, what load balancer you're using.
I agree. But I'm talking about the TCP based load balancer, network load balancer, right?
Yeah, IP port.
IP port. Different IP address and
Different, same port.
same port. Is that, do you have that one?
No.
The single, see, it's not three application I'm running. Think about it. It's opposite. Load balancer will not work. That means I cannot allow you to access. So here you have one IP address where multiple IP address needed, and we have a three different port where is a different IP address is needed and same port is needed. So load balancer will not work. Then how can you access that Facebook.com or LinkedIn.com or whatever? So guys, you suggested me operating system, single operating system. That was a superb idea, but this is not something which can be possible. So any more idea, guys?
Lightweight operating system. Not
Sir,
the
this is
full.
a lightweight only because lightweight, when I say very lightweight,
We can have different name. We can provide different namespace to them, and we can start these application in different namespace of the same operating system.
How? Tell me.
So we can if I mean again the concept of container will come in. Like we can have those applications inside a container which will have an isolation of which will have an isolation layer on top of the operating system. So when the process starts, it will allocate it a different namespace of all those four, whatever you have mentioned: the user namespace, the network namespace, the process namespace.
Yeah. So Ujjal said right, but have we got it? What he's trying to say? He's having right statement, but have you got it?
Yeah.
So you to suggest me.
To get our channel membership, click onto the join button, select the 3D99 plan, and grow your skills immensely.
Understand that, guys. Operating system, when I call it, you have a namespace already, C groups already, and capabilities already. When I say namespace, user namespace unlimited you can create. So here I created 1, 2, 3. That's wonderful. Now, when I say PID namespace, how many namespace you created? 1. But how many you can create? Multiple. So what has happened? Operating system says, I will not create more than one PID. I will not initialize more than one network. I will not initialize more than MNT, one MNT. That is where that we got a limitation this one. Then there is one guy. Are you understanding this, guys?
Yes.
Yes.
Yeah. So that is where there's one guy came and said, no problem. You don't do that. His name is Solomon Heights. Okay. His name is Solomon Heights. He said, this guy said, no problem. You don't do that. But I'll get it done. So what he did, he said, I will write one wrapper on top of your operating system. Okay, I will write one wrapper on top of application operating system. So this wrapper he has written. Okay, layer. Okay, this is one of the layer he has written. Now I will not interrupt your operating system at all. No problem. I will not interrupt. But what is having in the whatever in the operating system, again I'm repeating multiple times, so you should hard code this. In operating system you have a namespace. These are the namespace. These are the C groups and capability. So what they are saying, I will not interrupt your operating system, but what I will do, I will create one user. But from where? Okay, but from where? Namespace, which is here user namespace. So this guy will create one user, his own. And he said, after that, I will again create one PID net MNT. So here, each user, you got one PID, one MNT, and what is the next one? I forgot actually. PID namespace and what was that? Network. So he said, from where it is coming? All this is taking from the kernel only, without disrupting the current user and whatever it is. Okay, now he will create one more, and same thing he will do that. PMAP, network, MNT. He will create one more, and PMAP, network, and whatever it is. Now Apache will run here, here, here. And Apache will run on 80 port here also because of network. Here also 80 port. Here also 80 port. Apache can write because MNT also you got C drive. Here also you got. Here also you got. Here also you got. OPT here also you got. Here also you got. Here also you got. So C Apache and 50 PID, 50 PID, 50 PID. Now this is doable or not? You tell me. Doable or not?
Yes.
Yes. He did not do anything very strange.
Yes.
He did not disturb the PC concept. He just used his library to access the kernel and manage this stuff, manage this initialization. Now, guys, important thing is what is Docker? So, guys, this is called
The green layer, yeah.
Docker, and what is called container? This is called
Yeah, these are containers.
But Rajesh, I have a question over here. So you said OS does not allow you to create namespace. Is that what you said?
yeah.
So, like, if OS does not allow you to create namespace, then how did Docker create it?
So OS,
Docker.
OS.
Only one, right? Only one. So one, I think Docker has used that one, right? And then on top, then it's giving a few different namespaces.
Yeah. So when I say OS does not allow, that means OS will not do that. OS will not do that. When I say does not allow, that means maybe I use a wrong statement, maybe. But OS said, boss, I will not do that. Why? Because I develop operating system for the personal computing, not for your data center. Then this guy said, no problem. You don't do that, but I will do that with my tool. That is what he did it. So this guy will manage. That's the reason I said, if you read it here, that's the reason I said, what is Docker? It managing your container. Now, what is a container? We are discussing about that. So it's not about this OS will not allow. OS is allowing. It allowed because understand this way. Linux is an open source operating system, and Linux, all this Linux flavor has come from the GNU Linux. So all this thing you see, so you can modify this stuff and you can do that. Now, with the growing popularities, even Windows, which were not allowing opening up their architecture of kernel, they allowed that one. They developed that Windows support also for Docker. So it's like this. Are you getting my points? What I'm trying to say?
Okay.
Rajesh, Sai, yes, extension to Angela's question here. So I understand there is this Docker layer which actually creates these multiple namespaces for each of those containers. The is this that does it mean that is it like the only the Docker, the green color layer knows those namespaces and somehow maps it to the operating system namespaces, or actually the operating system knows the other namespaces? So what is the thing there?
So guys, see what happens when you have an operating system. This operating system know this, and this. Okay, and this is by natural some operating system based things, whatever it is. When I say kernel, okay, first understand the what is the operating system. When I say operating system, then we are talking about hell lot of things. We are talking about lots of library which was written by Red Hat, Windows, Microsoft, this that. I'm not talking about this one. I'm talking about the kernel. Okay, kernel and operating system is have a huge difference. Kernel, whenever you see of Linux itself, 40 MB, hardly 40 MB. But if you look at the operating system, it's like a 4 GB. And if you look at the Windows kernel, also hardly 200 MB. But if you see the operating system, 10 GB. So there's a huge difference between the operating system and kernel. On top of it, when I say kernel here, when I say it's a kernel, not operating system actually. Okay, so this kernel manage these also, I mean directly, and with the help of Docker, they manage this one also.
Okay. I think, I mean, the question is that, Rajesh, so I understand when we said operating system, we are referring to kernel here for sure. So what I'm saying is, assume that there is a namespace here, the network namespace. Say just gave it an N1 network name. So in a Docker, you want to give another namespace in a container. You have to create a N2 namespace for a network. So now what will happen is like the green layer here, which is the Docker. So it is actually creating that N2 layer. Is it that internally it is telling the OS that it is part of N1? Or actually, I mean, when to the kernel, it will say, okay, you add N2 also. So
Okay.
what is the,
So when you have asked, let me put it up in this way. So what is happening? Concept of things is whenever you boot your system, this is the kernel. Okay, Okay, and then this is the kernel, and this is the sum of the operating system file. Okay, so whenever you boot a system and whenever you log in, see, till login nothing is there, understand that. If you are not logged in, nothing will create it. The moment you log in, okay, they have one network created already, one mount created already, one what do you say, MNT created already. So this is already exist. Okay, now the moment you log in, this they create it, and they ask you use this one, use this one, and use this one. Okay, so this guy is Rajesh is forced to use this one. Now they again another people use a login, they've been asked this, this. When Docker creates when Docker creates that user, then they say don't use this, simple, don't use this, don't use this. This operating system guy is saying use this now. So here Docker says don't use this, I will give you one each one of you. Again more user, I'll give you one each one of you. So that way this guy dependent on this guy dependent on this, and all these four component is managed by Docker. But the question was, your question was, how this Docker takes this one from the kernel. Is it Docker can read this kernel? Answer is no. Kernel Docker cannot read the kernel. So what they use? They use container D. That's one of the layer which is written. So Docker manage the container. That's true. But Docker ask that resources for container D. Okay, that's a one tool. I'll show you the demo for time being. Theoretically understand. And container D can talk to the kernel. Here, Windows also can talk to the kernel. Okay, so this way, or Linux also can talk to the kernel. And there's a two kernel, by the way, in the whole world. One is a Linux kernel, one is a Windows kernel. Understand that. So this is two things. So here, this guy also ask a kernel, and this guy, you know that by default PC concept is where also ask kernel, and they release they initiate those resources, whatever based upon the request, and do the things. So this Windows operating system, when I say they manage the real user, the one which you are experiencing every day, but this CD gives to the Docker. Docker, this communication is very authenticate communications. That means very secure communications. So that way they Docker manages. Now when container D is there, they use one more tool to manage those resources, which called run C. I don't want it to confuse you too many things actually, because you get lost. So this guy also use run C, which you call it run containers environment. Earlier they were using libc. Okay, now it got replaced to run C. So I'm not getting into deep dive because you'll get confused with the flow. For time being, I'll let you think about it. Docker is managing everything for time. Will that be okay?
Yes,
So,
yes, Rajesh.
Rajesh?
Nice.
I have uh, Rajesh, I have one question. So, here Docker is just a facilitator, isn't it? I mean, we can have our own we can have our own containers as well, where we can provide a namespace,
Yes,
separate
guys.
namespace.
If you want to create, understand that Linux, there's a command line available where you can create a one user space, and you can create one network, you can create a mount, you can attach this user with a network mount. So see, first you create what? Very simple concept, guys. All these commands are available. You create one network, you create one mount, you create what else? One PID, and this attached to the one of the user. This can be done manually also. This is called kernel programming. Manually also you can do it. There's a command available. Let me show you here. Kernel namespace command to create network. All these things you can do that manually, but basically they are doing, Docker is doing for you to avoiding so much of complexity in your learning, I mean using process, because your purpose is not to learn these things. See here, process network namespace management. So you can see here, you can add, attach, delete, set, identify, many things you can do that. So this is the, you can do that also. Make sense?
Yeah,
Yeah.
But
Yeah,
you don't have to
Rajesh,
do that because Docker is doing on behalf of you. So basically, what is Docker? So Docker has made it everything so simple for you, so you can enjoy running applications. Forget about rest of the things and build technologies. So that is the abstraction, you can say.
Rajesh, I think just before this Docker has come in, we used to use this LXC kind of thing, similar
Right, right,
in
right.
Linux,
Like,
right?
yes, yes, yes. Actually, you know one thing. Before, see, this evolution of this one is right now we are using runc. Docker is using runc. Before this, they were using libc. Before this, they were using LXC. But you know, LXC is one of the project which was keep changing a lot. So the whole industry wanted to create a standard for it. So they decided, let's do one thing, let's use a cd only container. What is this container d? And for everything, so container d is a become a global platform to accessing the capabilities of kernel. Container d, you should read more about this. See, industry standard for what? Container runtime. So everyone uses container d. Even Docker uses Rocket. I think it also uses the same one. So like that. So LXC used to be earlier in, let's say, when I started learning Docker 5 years before, then it at that time they were using runc. Sorry, what is that? LXC. LXC.
Okay, okay. So basically, container D is like a superset of LXC and more standardized, right?
And
So
it's because it's like because they were having lots of challenges when the concept logic is changed in the LXC, then entire Docker will stop working. Docker will not work, then container also will not work. So they got frustrated. So they said,
okay,
let's not fight. Let's do one thing. Let's create one global standard for all containers, and they came up with
okay,
this container D.
sure, sure. Yeah, thanks, Rajesh. Helps.
Guys, so now the question was what is container. So guys, now you hopefully you understand that. So when I define what is a container, let's try to define here. Where is that? So what is a container? So guys, container basically technical. First I'll give you the technical definition. Container is basically is a user namespace attached to, let me copy paste because I don't feel writing. Okay, attached to one PID, one net, one MNC. Who's doing it? Docker, with the help of Docker. Docker is taking capability from where? Docker is
Ready.
asking for from container D, and container D is taking from where?
Kernel.
Kernel. Now you know that. So container D is from taking the capabilities from kernel. There's a lot of spelling mistake you might see. So I'm so sorry. I'm not so much focusing on each and everything. So please understand this. So guys, this is a technical definition. Okay, is a user namespace. Here there's a user namespace. Okay. Now if I say what is a container in a generic way, so I think someone has already explained self-contained environment to run application. That means self-contained independent environment. There's no dependency. That means you can run any independent environment to run any applications. And this is the right definition for container. Okay, and its organizations we have already discussed. So guys, did you understand what is a container now?
Yes, Rajesh.
Yes.
Yes, Rajesh, by
Yes.
definition, are we suggesting container will run only one application?
No, sir. It will container. Okay, one more thing. Yeah, this is a good question. Actually, you must be getting confused. So here, when I say one applications, where is my image actually? So when I say, just again, let me open up. So when I say one application, let me tell you, this is your main applications which you want to run in a data center. You don't want to run 20 applications. But here, for running Apache, you need a JDK, right? You need some other dependent services. So you can run as many applications. Let's say user. Think about it. You are thinking container is a different guy. Don't think this is you. Yes, you are the containers. I am the containers. We all are container. But the problem with us is we are shared containers. These containers are independent containers. So can you not run 10 application? You logged in and you not run? You are allowed to run only one application? No, you see that how many applications I'm running. See, I'll show you the process. And where is the user process? I can see here somewhere.
So Rajesh, still a container is similar to a user space, user application space. Right?
Yeah, see, sir, look at this here. These all applications I am running, but when you access from the container from outside, you have to tell, right? Think about the data center. You are thinking about as a laptop. No, don't think about as a laptop. Think about the data center. You are running so many applications, but ultimately front end will be only one applications, right? Which you want to access in the data center. So this is what I'm talking about. Getting my points?
Okay.
Okay, so now yes, this is the things. So guys, any questions, any more confusion? Here we have a container.
Yeah, one question. So, is there anything that stops this Docker to create more than one network namespace in a container?
Guys,
Because now it is independent.
I'll put it in this way, guys. I'll put it in this way. Do you know how many users you can create in one operating system? Forget about the containers and forget about the Docker. Do you have that number? How many maximum number of users you can create? Hello, I'm
No,
audible.
not aware, not aware.
Yeah, so there's
No.
no limitation actually. You can create. It's about, if you remember, I was talking about the class and object instance. So something similar actually. Do you have a number? How many? How many? If you're a programmer, you know that how many instance you can create of the classes? Unlimited,
Yeah,
right? So it's
yeah,
like that. It's like that. Yes, the limitation comes to the CPU and RAM. That is a limitation because you can create only that number of users which your CPU and RAM can hold it, which can a storage can hold it. So yes, there is no limitation which I am aware of it too, as like similar to you. But I know that if you create a too many users and if your CPU is not holding that, I mean it's stuck, then what is the use of those? So it depends on the experience with applications and the users of the CPU and RAM who will do that stuff.
yeah. Sure, Rajesh.
Okay, guys.
Yeah.
So now,
Rajesh, one more question.
yeah, please tell me.
Rajesh,
Yeah,
able to?
yeah, I can hear
Yeah.
you.
So in the same, when you say the namespace and all, right? So we are actually creating a separate PID, separate mount point and everything. And you mentioned like there are some command we can create that. Okay. So who stops me from creating the same thing from a container, or
Ha.
the container won't have accessibility to those things?
Wait. Container is not at all need a accessibility. If you look at the image, a Docker need that accessibility. Container is managed by Docker here. So
Okay.
probably you want
So
to rewrite the
means I
questions.
don't get the complete kernel in my. So do I get the complete kernel in my container? No, right? I just get the PID, the namespace, and these things. But there will be still something extra over and above, which actually Docker is managing, in which the individual container may not have the capability, right?
No, of course you know that it should be very fair. No, kernel you have only one. That's a kernel you have only one. There's no multiple kernel here.
So I cannot create a nested concept here, right? It's reluctant for me.
What is that?
So means a container having another container, that's not possible, right?
No, sir. You are saying it's like this. Let's say you and me is
Okay.
into my laptop.
Yeah. So sorry. Maybe. Yeah.
Yeah, it's don't think container
Yeah.
is special. Again, I'm repeating same thing. You are container. I am a container. Can you create inside me? Can you create inside me? Can you log in inside me? No, we both cannot. We have to
No.
coexist together. So container is something similar that, but the management tool is become a Docker instead of the operating system companies.
Shreyan, sir, please don't. I think don't confuse with the virtual VM and the container. A container is not the VM.
Okay.
Yeah, container is not VM. Remember, I also discussed the VM. You have operating system here. You see
Yeah.
operating system. Here we do not have operating system. I never said in container you have operating system. That's a one person said. One person said if you delete the operating system, probably we can run more applications faster, better, and cheaper. So that's what we are doing actually. So now the question is, what is the advantage of container?
Okay.
Advantage of the container, guys, how much time it takes to create a user? Millisecond. So you can run container in a milliseconds. If I can run this container here in my platform, same containers you can run in your platform. That means dev, QA, production, you can use the same containers. So you don't have to runtime environment problem like this library is missing, that library is missing. It's a complete independent. Someone only taught us it's a complete self-contained independent environment to run any application. That means if you can run containers, same containers here, it will behave in the same way. If you run in other places, it will behave in the same way. No independent packages needed apart from the container runtime environment. Okay, so these are the speed you get. Again, containers consume less CPU, less RAM, less storage compared to virtualizations, because virtualizations you have operating system also. So operating system also consume lots of CPU, lots of RAM, lots of storage, licensing cost. Hypervisor also consume lots of CPU, lots of RAM, lots of storage. So this wastage got reduced in the world of container, so you can run faster, better, cheaper, and do the CI/CD and DevOps also. So this is the Docker. So guys, what is a Docker? Yes, it's a container management tool. Okay, this is written in Golang. Okay, written in Golang. Now, who's the written by? Written by Solomon Hykes. He has resigned from the Docker company. Now there's a release, actually various releases are there. One is a CE release, which is called Community Edition. Okay, and there's a EE release, which you call it Enterprise Edition. I'll be teaching you Community Edition. Now, which is the latest version which you have? If I'm not wrong, I think 19x. I have a very bad memory though. So this is the one. Now guys, this is a free and open source. This is a paid one. Okay, now this is the one. So yeah, this is the Docker. So guys, I'll talk about the Docker architecture in little bit time. Okay, so guys, this is a Docker, this is container. Make sense?
Sure.
Please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan, and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.